Hey guys, or hey Zach. Okay, so I'm gonna try to make sure that I keep this right here, and I've got it on full screen so I see it really good. All right, so this is the formula you're gonna use with Newton. Okay, A equals force over mass. So acceleration is the unit is mass. Meters per centimeter. Sorry, meters per second squared. See, when my hand gets in the way, it's hard. Okay, and then shadows. And then force is newtons. And then mass is kilograms. So a newton per kilogram is actually equal to a meters per second squared. So here's the units you're going to use. So here's one formula you can use. I actually prefer this one. Okay? Or it's written like this. Okay, so this would be force, mass, acceleration. Force, mass, acceleration. Either formula is fine. G is gravity, which is actually gravity is the acceleration of gravity. So A and G are basically the same thing. Okay, when you put G, it's actually 9.8, but if you put acceleration, it can be anything, or it can be 9.8 meters per second squared. So these are the two formulas you can use. Okay, Newton's law is actually this formula. However, again, I like using this formula. Now, when I did the worksheet, the answers for it, I used force, the A equals force over mass on the entire worksheet, just to keep it the same. But I'll do it both ways maybe, okay? And I can't make this video very long, so I'm going to try to make it as good as possible. All right, so number 10. It says, what is the net force needed to accelerate? What is the net force needed to accelerate a 3 kilogram physics book with an acceleration of 13 meters per second squared? Okay, so what is the net force? You're looking for net force. You've got a kilogram book, that's your mass. So force, mass, and then you've got acceleration, which is your acceleration. Okay. So what I would do is use my force formula. Force equals, I'm sorry about the shadow. Force equals, that's not worse. Force equals mass by acceleration. So my force is what I'm looking for. My mass is 3 kilograms. And then my acceleration is 13 meters per second squared. Okay? So you just multiply your mass and your acceleration right here, and then you get your force. And with this one, 3 kilograms times 13 kilograms equals 39 newtons. Okay? Now, if you would have done it the other way, okay, which is this formula, okay, what I would have done is my force is what I'm looking for. My mass is 3 kilograms, and then my acceleration is 13 meters per second squared. Then I would have had to solve for my force, so the way I do that is get rid of my denominator. And when I get rid of my denominator, I have to multiply it, do the opposite. This is division, so do the opposite, multiply, and you got to do it to both sides. So here I'm multiplying, and here I'm multiplying. Those cancel out, because that would be basically over 1. Okay, and then these, you just multiply. So that's why I think if you're looking for force, the other formula is a little easier. Okay? All right, number 11. It says a tow truck exerts a force of 8,000 newtons on a car accelerating at 4 meters per second. What is the mass of the car? I'm sorry, that's kind of fuzzy. Okay. Okay. So I'm going to use my force formula again. Okay, you can again use anything, but I'm going to show you that this one kind of is easier for me, math-wise. Okay, my force is my newtons, force of. This is my acceleration, accelerating at, and it's got meters per second squared, so acceleration, and I'm looking for mass. Okay, so my force is 8,000 newtons. My mass is what I'm looking for. And then my acceleration is 4 meters per second squared. Okay? Sorry, that's an 8. Now I have to solve for my unknown right here. The way I do that is because I'm multiplying, I do the opposite, 4 meters per second squared, and I do it on both sides. If I do one thing on one side, that's 8,000, sorry. I do it on both sides. So these can cancel, so that I'm left with meters. Oh, just write it down here, sorry. And then 8,000 divided by 4 meters per second squared would give me 2,000 kilograms. Okay? Because a Newton per meter squared is equal to a kilogram. All right, so here's my answer. All right, so number 12, how much net force is required to accelerate a 1,000 kilogram car at 2 meters per second squared? Okay, I'm going to use my force formula again. Oh, sorry, I should have showed you this. Okay, so here I use the other formula. Okay, sorry. Okay, so I did acceleration is 4 meters per second squared over the force and looking for meters. I have to multiply my mass on both sides. And when I do, I can cancel it out. So then I would have 4 times m, okay? And then I would do 4 meters per second times m equals 8,000. Divide 4,000 on both sides. So 8,000 divided by 4 is 2,000 kilograms. I kind of like the other way. So either way, okay? 12, how much force? If I'm looking for force, I'm definitely going to use this formula. Okay, so I'm looking for force. My acceleration, my mass is this, and then my acceleration is this. So 1,000 kilograms times 2 meters per second squared. Okay, 1,000 kilograms times 2 meters per second squared. 1,000 times 2 is 2,000 newtons. Okay, so on this one, I used my acceleration, 2 meters per second squared, and here's my force, and here's my mass. I multiply my mass on both sides. Those cancel out, and then it's 2 times 1,000. And that gives me 2,000. Okay? All right. Oops, sorry. Okay. I'm sorry it's not clearer. All right. If gravity pulls on a bowling ball at a rate of 9 meters per second squared, and that's gravity, so that's also acceleration, towards the Earth, and it strikes the Earth with a force of 15 newtons, what is the mass of the bowling ball? Okay, so again, I'm going to use my formula, force equals mass over acceleration. I'm sorry, mass times acceleration. My force is 15 newtons. My mass is what I'm looking for, and my acceleration is 9.8 meters per second squared. Okay, so to solve for my m, I'm going to divide 9.8 meters per second squared on both sides. Okay, second. Those cancel. So 15 divided by 9.8 gives me 1.5 kilograms. Okay, I hope that helps. Call me if you need more help.